All right, so these are just some terms you should know, and these are specific matrices. So a row matrix is a matrix that has only one row. So an example of this would be like 1, 2, 3. That's a row matrix because it only has one row. A column matrix is a matrix that has only one column. Okay, so an example of this would be like 4, 7, 2. That one happens to have 3 rows, but it's only one column, whereas the row matrix that I gave only had one row, but it had 3 columns. All right, and then a square matrix is a matrix with the same number of rows as columns. So I'm just going to do a 2 by 2 matrix, just because that's easy. 2 rows, 2 columns. You can have 3 by 3, 4 by 4, a 1 by 1 matrix. It's just a single number inside the matrix C brackets. It's kind of cool. Okay, and a 0 matrix. You guys hopefully already know what this is. It is a matrix with only zeros. It does not matter the dimension, but it only has zeros inside. So an example of this would be like 4, 1, 2, 7, -3, 27, 6, and 5. Why not? Those seem like good numbers. Okay. All right. So, hopefully you're doing well. Now we're going to practice some adding some matrices, then subtracting some matrices, then multiplying by scalar, and then we're going to practice a problem. And then you guys are going to make so many of these, a lot of these. So when adding matrices, you can only add 2 matrices if they have the same dimensions. And then you do this by adding the corresponding elements. So 0 is in the spot 1, 1, so is -9. So we're going to add those two together. So 0 plus -9 is -9. Then we would do -4 plus 18. Well, -4 plus 18 is 14. Then we would do 12 plus 34. Well, 12 plus 34 is 46. Then we would do 23 plus -10. 23 plus -10 is positive 13. A -7 plus a -8 is a -15. And then a -5 plus 3 is a -2. So that is my resulting matrix when adding those 2 matrices together. All right, let's take a look at some subtraction. Subtraction is the same idea. They have to have the same dimensions because every number needs something to be paired with, and then you're just subtracting the elements. So this would be 27 minus -9. So 27 minus -9 will be 36. Then 11 minus 8 is 3. Then -5 minus 7 is -12. -3 minus -6 is going to be 3. 21 minus 2 is 19. And 7 minus 13 is -6. And again, we did that by doing corresponding elements. Another way you can think about doing this is you can just change this to addition and then change all the signs in here to the opposite. Okay, essentially you're multiplying through by -1, which brings us to scalar multiplication. So each element of a matrix is multiplied by the scalar number, or it's considered a constant, and a new matrix is created. So, for example, on this one, we are going to take this 3 and multiply it to every single element in this matrix. So I'm going to take it one by one because there are 9 numbers to do this by, and if I try to do it all in my head all at once, I will cry. So we've got 3 times 6, that's 18. Then 3 times 0, that's still 0, that's lovely. 3 times negative 5 is negative 15. 3 times 4 is a positive 12. 3 times 2 is 6. 3 times negative 4 is a negative 12. 3 times negative 8 is a negative 24. 3 times 17 is 51. And 3 times negative 1 is negative 3. All right, with that under our belt, let's go ahead and practice this problem right here. Right here, we're just doing some subtraction. So we're going to take our R matrix and our T matrix, and we're going to subtract them. So my R matrix is 4, 0, 3, 5. And I'm going to be subtracting my T matrix, which is negative 2, negative 3, 4, 0. Now, like I said before, you can actually think of this as a negative 1 and then distribute it through by changing all the signs. Obviously, negative 0, not super important that you change the sign on that one, but might as well. So now I can see this as 4 plus 2, and I get 6. Or 0 plus 3, and I get 3. Or 3 plus negative 4, and I get negative 1. And 5 plus negative 0, and I get 5. And that is my resulting matrix. I want you guys to go ahead and try these. Note that if you cannot add them, please write the word impossible. And as always, the answer is on the next slide. And please join me back at this problem right here where we add in some scalar multiplication.